Okay, this is the video for the cookie activity that I have used in previous stats classes when I'm actually in class with students. And I'm going to do this and I'm going to show you the calculator steps. So on the PowerPoint, and there's a calculator note sheet too, it tells you what to press, but I'll actually show you a calculator. My calculator actually is, I can't find mine, so I have one on the computer, so I hope you'll be able to see it okay. That way you can see what I put in. You can use the formulas, they're on the PowerPoint. They do take longer, but I do have them typed out for a couple things so that you can see how the formula is used, but probably you'll want to use the calculator just because it's so much faster. So this cookie activity, what I do is I give students a chocolate chip cookie from Chips Ahoy, and then we write the number of chips in the cookie on the board. And obviously some people debate on whether you count halves or quarters if you've just got a small chip or whatever, but I usually tell them if there's a black dot, just count it as a chip. So this was one of my classes numbers that we had. So then we have to decide if it's a sample or population, because you're always going to need to label on all of your assignments. So you need to know if you're going to use sample notation or population notation. And so this we say is a sample. We didn't use the whole pack of cookies. If the whole pack was used, you could argue it's a population because it was all in that pack. Or you could actually argue that it's a sample from a larger batch, because each pack of cookies doesn't, they don't just make one pack at a time. So I would say it's a sample regardless, but if you did use a whole pack, you could argue that that was a population. So sometimes it's sort of opinionated on whether or not it's a sample or a population. Hopefully on most of your stuff it'll be clear, like you'll see the word all of something or something like that to indicate that it is a population. So we're going to find the following and label using proper notation, and like I said, you can use the calculator if possible. So I'm going to go ahead and do the calculator. So what we want to do is type these numbers into the list on the calculator. So I hope you can see this on the computer. So we go to Stat and Edit. If I can hit Enter maybe. And then in L1 there, we're going to type all these numbers. So we've got 27, 17, 16, 17, 25, 24. I wish I could find my calculator. I could do this faster if I had it laying in front of me instead, but it's okay. At least you can see it done. 15, 19, 20, 25, 33, 30, 20 and 20. 14, 21.
Look. It's dry.
15, 12. 18, 26. 24, 12. 22, 16, 14. 16, 14, 17. Sorry, my son's running around. 19, 18, 18, 14, and 2 17s. Okay, so hopefully I typed them all in correctly. So after you're done typing your list in, you can press second and mode, which quits, gets you out of that list area. And then what we want to do to do any calculations, we go to Stat, over to Calc, hit Enter, and since we're only using that one list, you don't have to tell it what list, so you can just hit Enter, and there is your information. So X bar is your mean. It'll always say X bar. It won't say, it'll never say mu, because the calculator just always uses X bar, so that's where you have to know what notation to use. So we already said this was a sample, so we're going to use the X bar notation, and I didn't tell you how many to round on this. I'm just going to round to 2. So X bar for our mean is 19.69. The median, if you wanted to organize the data and find the median, you can, but if you press the down arrow, up here. If you go down, it'll say mean equals, so that's your median. So our median's 19. There's no notation for median, so you can just write 19. There's no notation for mode. Let me actually do the mode last. I'll come back to that because I'll show you a trick where you can do it faster sometimes. So let me move on to mid-range. So your mid-range is your maximum plus your minimum divided by 2. So if you look, instead of you having to find it, the calculator tells you your max and your min. So we'd have 33 plus 12 divided by 2. There's no notation for mid-range, so you just write it. It's equal to 22.5. Our range is our maximum minus the minimum, so we've already got that on the calculator. So that's 33, the max and the min, minus 12, which is 21. And for some of these, you know, you could go through and find that as well. It's just the calculator gives it to you. You can save some time sometimes. Standard deviation for a sample, we're going to look at S. So you need to scroll back up to get to S. And remember, the calculator gives you S and sigma because the calculator doesn't know if it's a population or a sample, so the calculator will give you both. So you have to know, do I use the population number or do I use the sample number? So we've already said it's a sample, so we're going to use SX. Now remember, the calculator notation is not proper notation, so it's just S, so you leave the X off. So this would be 5.298 bumps up the 9, so 5.3. So S is 5.3. And then for our variance, you're going to do S squared. And when you do variance, you shouldn't round. You shouldn't use the rounded value. It throws it off. So if you know how to get the calculator to pull SX from store, like it'll save it as if you go through and find SX, you can do that. Some people forget where that is, so sometimes it's easier just to type it in. So 5.298 944 964 squared, and hit enter, and we'll round to 2 again. So 28.08 is our variance. 28.08. And going back to the mode, so you can obviously look up here and count which one occurs the most. But one kind of quick way to do that, and that way I can show you another calculator trick, is if you go back into stat, you'll see that it says sort A and sort D. Sort A is sort ascending, sort D is sort descending. It doesn't really matter which one you pick. So I'm going to do sort A for ascending, and you have to tell it which list. So second one tells it to use L1. Hit enter, it'll say done. Then if you go to stat and edit, your list is now in ascending order, so smallest to largest. If you do sort D, it'll do largest to smallest. So either one you want to do. But that way you can look, so you've got 2 12s, and then here you've got 3 14s. So it groups them together, so that means you can usually find your mode a little faster. 2 15s, 1 16. There's actually 4 17s, so far that's the most. 2 18s, 2 19s, 3 20s, a 21, 22, 2 24s, 2 25s, 26, 27, 30, and 33. So 17 would be the most because it occurred 4 times. So that way it kind of clumps them all, so then you don't have to go through. For this number of values, it's not too bad to find using the table, but if you have a whole bunch of values, sometimes that's a little bit faster if you go ahead and sort them on the calculator. And that's also helpful if you want to sort just in general. You can sort any list like that. And mode does not have notation, so just write 17. So for that one, I did it on the calculator. You can do it by hand, and like I said, the PowerPoint has the formula if you prefer doing the formula. The mean's not so bad. The standard deviation one takes some time if you do it using the formula. So for the next page, we have, is 10 chips in a cookie unusual? And you always need to show your work. So to do unusual values, your minimum usual value and your maximum usual value, is found by taking your mean plus or minus 2 times the standard deviation. So we're going to, for the minimum, you subtract, so x bar minus 2s. For the maximum, you add x bar plus 2s. It's okay to use rounded values. You just need a range of numbers. So it's not usually using rounded values on usual numbers. It's not a big deal. So if you look at our last page, x bar is 19.69, s is somewhere down there, 5.3, and then we're also going to do the max, we add them. So if you do both of those, you should get 9.09 for the minimum and 30.29 for the maximum. So if it's asking is 10 chips unusual, the answer would be no, because 10 is between these two numbers. So 10 is not unusual. The only value we had that was not in between those two numbers is our maximum of 33. Our other high number was 30, but it's between 9.09 and 30.29. So I'll just make a little note over here that if it asked about 33, the answer would be yes, because 33 is not between these two numbers. So that's all you have to do for unusual numbers. You do the min and the max by doing your mean plus or minus 2 times the standard deviations, and then check to see if whatever number it's talking about is between those two numbers, or it may say, is there any unusual values? So then you just look to see if that was the question, we would say 33 is unusual. So for number 5, we want to construct a box plot, or a box and whisker plot, whatever you want to call it. So to do that, we need our 5-number summary. So that consists of our min, our quartile 1, our second quartile or median, our third quartile, and our max. We've already talked about the min and the max doing the range. So we already said that that was 12 and this was 33. To get to our other values on the calculator, since I've done other stuff, I'll have to just do the stat calc again. And if I scroll down, the 5-number summary is at the bottom if I hit the down arrow. So Q1's 15.5, the median is 19, which we already did 2, and then the Q3 is 24. So to draw our box plot, we draw a number line, and we need to go from 12 to 33, so I did 10 and counted by 5s. It doesn't have to be exact. So we draw a box between Q1 and Q3 with the line at the median. So we have 15.5, which is maybe about right there, to Q3 is 24, so that's about right there, and that's our box. And then our line at the median is 19, which is about right there. And then we go draw our whiskers to the outlier, to the, not the outliers, to the min and to the max. So we've got one at 12, and then one at 33 at max. Well, it's not very straight, but that's okay. And if you want, you can mark these down here. Well, that's 15.5. I can't hardly write that in. So I'm going to write it super small. And then this is 19. This is 24, and that's 33. But you'll always be asked to list it over on the side anyways. So just as long as it looks remotely close, it's fine. So there's your box plot. The IQR is Q3 minus Q1, so we do 24 minus 15.5, which is equal to 8.5. And then it says list any possible outliers. So some people get confused on the outliers versus the unusual numbers. Outliers uses the IQR, the unusual or usual numbers uses the mean and standard deviation. So to do the outliers, we do what's called the lower fence, which is you take Q1, so we 15.5, minus 1.5 times your IQR, which is 8.5. So that gives us 2.75. And the upper fence is Q3, which is 24, plus you add instead. So that's part's similar, 1.5 times your IQR of 8.5, which gives us 36.75. So for our numbers, our min's 12, our max is 33. So all of our numbers fall in this. So there are no outliers. If we had had cookies that were like 41 chips in the cookie, then that would be considered an outlier. That would also throw off all our other numbers too. But anyways, so don't get confused. Outliers, just remember, it goes with the IQR. The usual or unusual values go with the mean and standard deviation. To calculate the coefficient of variation, we just say the CV. It is your standard deviation divided by your mean times 100. And for the coefficient of variation, most books tell you do not round. So this is where you'd want to not use a rounded value. So you go back to the calculator and do S all the way out and X bar all the way out. So that is 5.2989. And the point in not rounding is if you're looking at two data sets and comparing them. For one data set, it wouldn't matter quite so much, but if you're trying to compare two or more data sets, you don't want to round because then you get a rounding error, so you want to be as accurate as you can. So just to be safe, just always remember on like variance and coefficient of variation, just don't round, so then you'll know when, you'll just remember to never round. So if you do that, you get 26.91%. And on the PowerPoint, we do compare the data data sets, which is what that's more useful for. So basically this is just making sure you know how to calculate it. So for the last one here, we want to create a frequency distribution of the data using 5 classes, then answers the questions, and still label using proper notation. So if we're going to do 5 classes, we need to do our class width, which is our maximum, which we've set as 33, minus 12, our minimum, divided by 5, and you always round that up. So that gives us 4.2, which is 5. So we always round up regardless. So we start with our minimum number, which is 12, and we go down. Remember, the class width goes down, not across. So 12 plus 5 is 17, plus 5 is 22, plus 5 is 27, plus 5 is 32. And then here we're going to go plus 4, or you can subtract 1, however you want to do it. So there's our classes. And the frequency, go through and count. If you've sorted your list, it makes it easier to count as well when you do the frequency distributions, because you can go back to stat and edit, and you can count how many is between 12 and 16. So we do 1, 2, 3, etc. I'm not going to do that just so the video is not so long, but between 12 and 16, assuming that I've counted correctly, there should be 8. 17 to 21, there's 12. 22 to 26, there are 6. 27 to 31, there's 2. And 32 to 36, there's 1. So it says find the mean of the frequency distribution. So you can do it on the calculator, or you can do it by hand. In order to calculate the mean based off the frequency distribution, you have to know the midpoints. So that part you have to do before you can do anything. So add them together and divide by 2. So 12 plus 16 divided by 2 is 14. 17 plus 21 divided by 2 is 19. 22 plus 26 divided by 2 is 24. 27 plus 31 divided by 2 is 29. 32 plus 36 divided by 2 is 34. So you have to do the midpoints first. And then you can use the formula if you want to, where you multiply the midpoint times the frequency, add them up, and then divide by the sum of the frequencies. That's fine. It is faster to do on the calculator, so I'm going to show you how. So what we want to do is we want to type our midpoints into L1 and our frequencies into L2. So if you're in Stat and Edit, so I'm still here because I was in there just a minute ago. Oops. Well, okay, quit hitting buttons, Ann-Delyse. If you go up to L1, and we don't need it anymore. You could use L2 and L3, but I'm just going to get rid of L1 altogether. Hit clear and enter. It clears it out for you. So type in your midpoint. So we got 14, 19, 24, 29. Oops, sorry. Can't look and hold the video thing. 34. Then go over to L2 and type in your frequencies. So 8, 12, 6, 2, and 1. And again, when you're done with that, hit second mode, get out of there. And I'm going to clear all this off so that we can have a clean screen. So to find the mean, using not one list, but two lists, because you're using the midpoint and the frequency. So remember, if you use the formula, you multiply them together and add them up and then divide by the total frequency. So we're going to go to Stat Calc. You still pick number 1, the first one, for one var stats. But instead of using one list, we're using two lists. So we do second L1, which is where our midpoints are, comma, second 2 for L2, which is where our frequency are, and hit enter. And there's all your stuff for the frequency distribution. So it's still a sample, so we're going to do X bar equals 19.86 in this case. And if you look, that is close to 19.69. That was what we got when we used the original data. The mode of the frequency distribution. So if you look at the mode is the one that occurs the most. So the highest frequency is 12. If it asks you just for the mode, you use the midpoint. You assume all the values are the midpoint. So we would say 19. But C says find the modal class. So the modal class wants you actually to list the class. So 17 to 21. And we know the mode from the original data was 17. So it makes sense that the modal class would include the mode. The standard deviation of the frequency distribution, go back to your calculator. We're looking at SX because it's a sample, so it's 5.19. But remember, when you do it on the paper, it's just S, so 5.19. That is close to what we originally got, which was 5.3. And for our variance, again, don't round on variance, so you want to go to the calculator, type in 5.18, 737, 5733, and square it. So you get 26.91, so S squared is equal to 26.91, which is close to our original variance from the original data, which was 28.08. So basically your homework, you'll be doing this same thing, just with different numbers, obviously, but this is a good example to follow using this set of numbers. And your homework will ask you about obtaining original data values based off the frequency distribution. The max, you don't know, because we know the original data, so we do know our max was here 33, but 36 isn't the max. 36 is the top of this class, but 33 is in here, obviously. The only thing that we know is we can get the min, because we always start our frequency distributions out at the minimum data value. So our minimum is 12 for sure, but when you do maximum, you can't just assume the maximum is 36 because you don't know if it's 32, 33, 34, 35, or 36. So the minimum value we know is 12, max you can't just assume. So if you have any questions on the homework or about any of this, please just let me know.